Well, I had noticed that the y-axis stepper motor and the y-axis stepper driver heatsink on the board is getting too hot, perhaps 3 times hotter than other heatsinks or the stepper motors. And so here are the things that I fixed to make it cooler. First, here it is the x-axis motor, and there it is the y-axis motor, and the bed moves along y-axis plane in this direction. I squared the bed using the nuts here so that there is no tilt or no bend, and the tension in the belt is comparable to that in the x-axis. Still, y-axis motor was getting hot, so what I did was, um, I swapped the wires of the x-axis with the y-axis and the limit switches also. Still, the motor that was along the x-axis now was getting hotter. So I thought that the current was being given from the board too high as compared to the motor on the through the other stepper driver. There is only one variable resistor that is there. Let me show you here. For the z-axis motors, all of the other stepper drivers have fixed resistors to control current to the stepper motors. So here it is the x-axis stepper, the driver, the heatsink you can see, and it is 18C, which corresponds to 15 kilo ohm. This resistor controls the current to stepper motor. I do not know what value is this, but for this value the x-axis motor does not get hot. And for the y-axis here, it is 273 SMD resistor, which corresponds to 27 kilo ohm. I googled it. So for extruder E here, the stepper driver heatsink here is, and it is 18C, 15 kilo ohm, I mean, for the extruder. For the x-axis, the motors which are not getting hot, while the motor that is getting hot, it is y-axis motor, which has more resistance, which means more current going to stepper motor. Perhaps the company gave more current to y-axis because they thought that the hotbed or the printing plate could be heavy to move along y-axis. Perhaps this was the reason they gave it more current. So I used a multimeter to confirm the resistance along the 18C and the 273 SMD components, and it came out to be really 15 kilo ohms and 27 kilo ohms. So what I decided was not to mess with the bed, just to attach another resistance in parallel with 273 to make it from 27 kilo ohms to 15 kilo ohms, so that the current will be decreased to the y-axis motor. Here I used the online calculator where you can put in the value of R1 to get the final and the resistance in that you want as a final result. I put in 27 kilo ohm and the final result to be 15 kilo ohms, and it gave let me correct it, 15,000 ohms and 27,000 ohms and 15,000 ohms. That would give the final resistance to be 33k. Okay, 15k, 27k, 27k, 15k, and 33k. So 18c is 15 kilo on y-axis, 273 is 27k along y-axis, 15k along axis, sorry, and the resistance of 33k in parallel would make the final resistance to be 15 kilo ohms, right? Along y-axis, limiting, decreasing the current now. So theoretically, the motor should not get hot, the stepper driver heatsink should not get hot. So here it is, the 33 kilo ohm resistance. The wires will be attached to the solder to the board, while the resistor will be soldered to the other end. I will not mess directly with the board using the resistor. Here it is the wire that is soldered, and here it is the resistor soldered to the wire. So here I have been printing. It's around 50% printed, and well, quite good printing along y-axis. No missed steps when the current is decreased. And I already told you that my my frame squaring is very good. So as per good assembly, the bed moves along y-axis very freely. So the motor is quite similar in hotness as compared to the x-axis motor. And the heat sinks for the stepper drivers, well, these are also comparably hot. Previously, the y-axis stepper and the stepper motor driver heatsink were very very hot, burning hot, and now these are comparably hot. So let's compare with the thermometer. Either it is the digital infrared thermometer, which will give instantaneous spot readings. The temperature on the stepper of x-axis is around 95, 96, 95.9 degree Fahrenheit, and the y-axis stepper motor is at 96.3 degree Fahrenheit. Comparable. Let's see. It corresponds to around 35 degrees Celsius, right? The x-axis motor again is at 96.8, so comparable. And the specifications of these stepper motors that Anet has used, it says that this could be hot till 50 degrees Celsius, right? So the heat sinks here is the x-axis heat sink. It is at 97 degree Fahrenheit, 97.7, and the y-axis heat sink, it is at 90, compare with the x-axis, 99 degree Fahrenheit. That corresponds to 39 degrees Celsius. So still quite reasonably warm. Okay, reasonably hot. Well, here is let me show you the final insulation I have done using a cello tape, and it is attached to the printer board using tape. Simple, because there will be no manipulation further. I hope you like the video, and if you have any comments you can share, and do subscribe me. Thank you very much.